In this video today, we're going to look at the focal diameter and how that relates to the equation or the letter P on the equation of a parabola. So specifically, we are approaching this through a conic sections lens, and we're talking about parabolas centered at the origin, although the same math would apply for anything shifted left, right, up, or down. So what is a focal diameter? It's the diameter across the parabola, I'll mark it here in purple, that goes right through the focus from one side to the other. So that distance of that purple line that I just drew, that's the focal diameter. So to find that, let's re-examine the geometric definition of a parabola, which is that it is the set of all points that are equidistant from the focus, which is half of the focal diameter, show that right there, to the directrix. So if I had drawn that just perfectly, those two green lines would be equal. It's a little difficult to hand draw the focus and get that completely correct. So, but imagine those two distances are precisely equal. Well, since we know that the distance from the directrix to here, right from here to here, is P, so that distance is P. That is what I'm referring to as the distance from there to there. That's P. And then the distance from there to there is also P because the distance from the vertex to the focus is P. So we know that this total distance from the blue line to the red parabola is equal to 2p, which then means that this distance right there also equals to 2p. And since it is symmetric about the origin, that total distance from there to there, which is your focal diameter, is 4p. Now, technically, p can be negative, so we want to have, if we're talking about distances, the absolute value around all of those. So the focal diameter of a parabola is equal to the absolute value of 4p. And just as kind of a side note, the distance, half of that, the distance from the focus to the parabola is also called the lattice rectum. So if that is something you need to find, it's equal to the absolute value of 2p. That's the distance from there to there. Next, let's look at this example. We're going to find the focus, directrix, and focal diameter, specifically of this parabola, which is y equals to 1/2 of x squared, and we will sketch its graph. So first thing we're going to do is put it in standard form, and we're going to do that by solving for x squared. So if we have y, I'll rewrite it over here, y equals to 1/2 of x squared. If I multiply both sides of that by 2, then we're going to have 2 times y is equal to x squared. Okay, and usually we write the x squared on the left, not that it really matters, right? But we can compare that to the standard equation, which says that x squared is equal to 4 times p times y. And so setting those coefficients of y equal, right, we can set those equal, and we get that, okay, 2 has to equal 4p. That gives us a little equation that we can solve for p. So if we divide both sides of that by 4, we get, I'll reverse it around too, p is equal to 2/4, which simplifies to 1/2. All right, so from there we can then state the focus and the directrix, right? So the focus, now this is y equals x squared, and it's going to open up because p is positive. So the focus is at 0, comma p, so 0, comma 1/2, and we can put that on our graph right there. There's the focus, which is at 0, comma 1/2. And the directrix is always on the opposite side. If you're centered at the origin, it's the opposite side of the x-axis. So it's going to be down here at y is equal to negative 1/2. It is that horizontal line. So we're going to go right through here. Okay. There's that line. That is the directrix, negative 1/2, because it's always y is equal to negative p. All right, so to sketch this parabola, I'm going to plot a couple points. The vertex is going to be at the origin, and because it has not been shifted at all, as you can see. If you plug in 1 by hand, 1/2 times 1 squared is 1/2, so it's going to go through 1, comma 1/2 right there, and also negative 1, comma 1/2 through symmetry. And let's also plug in 2. So 2 squared is 4, times 1/2 is 2. So it will hit 2, comma 2, and also negative 2. Comma 2, and just kind of trying to curve that in a little bit, we get a nice little parabola. All right, there's the sketch of that parabola. And let's sketch on here the focal diameter. We haven't even found that yet. So the focal diameter is that distance from one side of the parabola to the other through the focus. So you can see from here through that focus to there. So in green there, I've sketched the focal diameter. In general, we just found that the focal diameter is equal to the absolute value of 4 times P. And since P, we got to be 1/2, right? It's equal to the absolute value of 4 times 1/2, which is 2. So the distance from there to there, that focal diameter is 2.